Okay, this next video I'm going to talk to you about the actinomycetes or the actinobacteria. Okay, so from the term itself, bacteria, these are not, you will understand that these are prokaryotes which are bacteria. Okay, and not only that, they are gram-positive bacteria. Now, I had done the experiment, I have already made a video. One day when I will upload the practical video for you, because me and the teachers, all us teachers, we went to the college and we did the practicals, and then you will see how I stain the gram-positive bacteria, gram-negative bacteria. Okay, you will see. It is very, very easy and interesting also. Okay, so what are the actinobacteria? They are a group of, what happened? They are a group of prokaryotes which are gram-positive and they are bacteria. Okay, and their structure is like filaments. Okay, they are not round or spherical or globular like the mycoplasma. No, remember, these are filamentous. Okay, so these filamentous bacteria, they look like fungus. The fungus, like when the hypha, like when the fungal hyphae, it's like this, right? Then one spore is coming out, long, filaments. So because they resemble the fungal mycelium, resemble the fungal mycelium, before the scientists, they thought that this looked like fungus, so it must be fungus. But they are not fungus, they are thread bacteria, okay, or ray bacteria, right? The cell wall and internal structure of the actinomycetes are similar to bacteria. So just by looking at them, they look like they have fungal hypha, no? But just by looking, we cannot judge a book by its cover, no? So when they studied the cell structure, then they realized, oh, they have a similar structure to bacteria. So not just similar, they are complete structures of bacteria. Because they look like fungus and they act like bacteria, so they are in between, no? So they can be a connecting link between fungus and bacteria. Okay, let me say again. Why is the actinomycetes a connecting link of fungus and bacteria? Because they have the fungal structure, filamentous structure, but they have the cell structure of the bacteria. Okay. So they are true bacteria, they are not fungus, and are placed in the kingdom bacteria. Okay, hence the new name is actinobacteria. Okay. Then they are ubiquitous, means they are found everywhere. Okay. They are found in soil, in tree, in leaf, in stem, in root, everywhere. Okay, found everywhere. They act as decomposers, and they act as decomposers which carry out the decomposition of organic compounds, blah, 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 blah. So most of the decomposition is done by actinobacteria. Okay, so when you have your dead leaves or your dead animals, dead insects, most of the decomposition is done by them, by these actinobacteria, because they are found everywhere. Okay, like when it rains. Right now I'm making the recording and it's cloudy and it's about to rain. After it rains, you just take a deep breath and you smell. Okay? You take a deep breath, you can smell the rain. That smell, no, it's actually the gas that is released by these actinobacteria. When it rains, no, they react with rainwater and they produce some sort of a gas. So the smell of rain, no, some of you says, I love the smell of the rain. You should say, I love the smell of bacteria. Because you're actually smelling the products of the bacteria. Okay, then let's look at the external and internal morphology as well as the habitat. Their external morphology, the size is 1 to 2 microns, micron meter in diameter. They are rod-shaped with a filament and branch structure, and the filaments contain muromeric acid. Okay. They are mostly aerobic, means they need oxygen because they are in soil and grass and tree and all, no? But there are few which are anaerobic and few are facultative. Now let's look at the internal. The cell wall internal structure are like bacteria. Maybe I need to underline what I'm reading. The cell wall contains mycolic acid. Reproduction is slower than bacteria and fungus. Hence, they are slow growers. Okay, they cannot reproduce as fast as other bacteria and other fungus. They have 60 to 78% of guanine and cytosine content. Okay, these guanine and cytosine are your DNA bases, right? Your nitrogenous bases. So they are very much abundant in soil and in the ocean, in the marine habitat. They are non-motile, they cannot move. They don't have any encapsulation, they don't have any covering, and they do not stain with the acid-fast stain. So they are not non-acid-fast. And they can grow in the alkaline environment. So they are slow growing, they can grow in alkaline, they are rich in guanine and cytosine, they are abundant in soil and marine. And what else? Most of them are aerobic, few are anaerobic and facultative. They don't have encapsulation and 1 to 2 micrometer in diameter, and they are filamentous and branched. So some of the economic importance, they are used in bioremediation. Okay, bioremediation means when an environment is so damaged by chemicals or by pollution, so you want to bring back that environment to its healthy state. So you use these bacteria, okay, so that the soil becomes healthy again. They will clean the soil from those maybe harm, heavy metals or harm, radioactive metals that seeped in, okay, whatever pollution that seeped in. So when you reclaim a land to make it healthy again, that is bioremediation. Okay, they digest complex carbs like chitin, cellulose, hemicellulose, all these trees and all, no, they have that. And they can degrade toxic compounds from environment. So they play an important role in bioremediation. Okay, next, biomedical use, because all the medicine that you are drinking, even if you are affected by COVID, you will have to take medicine from actinobacteria only. All the disease you have, okay, whatever antibiotics you get, no, most come from the actinobacteria. Like here, tetracycline. Tetracycline is an antibiotic that they use, I think, when you get what is that? Tuberculosis, no? Then neomycin is for your skin infections. Okay, all the antibiotics you get from this one, actinobacteria. Then they can be used to regulate plant growth. Okay, because they like to live in a place where there is a lot of plant hormones and enzymes. Okay, so once you know that this place has lots of actinobacteria, it will be good for plant growing. Then in industries, they have many ranges in industries. We can use them in the detergent industry, in the animal feed industry, okay, in the textile and paper industry, because they can digest the cellulose and all. So in the textile industry, you have to digest cellulose to make cotton. You have to digest the cotton to make the cotton t-shirt. No. So some examples are Frankia. It is symbiont, which produces root nodules and will fix nitrogen. Okay, this is the bacteria inside this root nodule of the alnus tree is Frankia. Then you have Streptomyces. They live in the soil and they impart, like I said, the earthy odor. Okay, when you smell the soil doesn't have any smell. Suppose you grab a soil and you smell it. soil doesn't have a smell of its own. It's because of the actinobacteria that's present in the soil. They are the one that emit the smell. Okay, so when it rains also, when you smell the rain, it's not the rain, that's giving the smell, it's the actinobacteria. So I'll upload this now.